Hey guys. Hey Michael. Oh, Michael not here. Now he is. Hey Donna. Yeah.
How's it going?
Yeah. Let's probably wait for a couple minutes. I see the people still joining. So for today's agenda, we basically ask Michael will take the lead to discuss about the BGP picks. So he will introducing the BGP picks. Then we will probably later on to see how we want to handling it. But my goal is say bring in the BGP pick into the FRR so we can get a better BGP routes convergence. So that's the main goal I would have. Anything else before we start? Okay, good. Michael, you want to take the sharing and take the lead to start the discussion?
Sure. Yeah. So hi everyone. I'm Michael McKenzie. I'll be describing the BGP pick IETF draft. So I don't think I've really introduced myself here before. Just a little background. I'm one of the engineers at Cisco responsible for the routing infra team. So specifically the RIB component, the label manager, and the SRv6 SID manager. So I got my hands dirty once in a while in sort of the PI FID, but haven't done much of the control plane, haven't done any of the data plane. So those are kind of my blind spots while I'm describing this draft. Let me share. Stop too.
Right now, the 15 is in Ottawa, or is still some part in the San Jose?
FID team is like the platform independent FID team that we're all in Ottawa. Yeah.
Oh, all in Ottawa. Okay, I see.
Oh wow, Zoom is asking for permissions for everything. Let's see.
Yeah. Oh, we can see your window.
Sharing? Okay, better. So I'm going to make use of the slides that Ahmed from Cisco had presented to IETF 94. Reuse those to make my life a little bit easier. So we'll start off with the problem, the solution. We'll probably initially skip over the handling of limited hardware capability. We can come back to that. And then I'll describe the different recovery for the failure scenarios. So problem. So what are we trying to achieve? BGP, because of its serial nature, is generally a little slow to converge. So we want, and we know that for some of the failure cases that we're trying to speed up, IGPs have been around and they can quickly tell when a core link has gone down. They can converge pretty quickly. And we want to see how we can have BGP leverage that information as soon as possible. So if a path is lost or gained, we would like that to happen independent of how many BGP prefixes are using that link. Yeah, that's the main goal. So it doesn't matter how many BGP prefixes use these links. If IGP can learn their new convergence as soon as possible, they should leverage that information. Some of the terminology we'll be using in here is a leaf. That's like a prefix or a local label. path is a way to get to the destination. It could be primary backup. Path list is an array of these paths, and each one carries an index. The out label array, so we kind of keep that separate from the path list, but they're associated with each other. So path at index 0 should use the labels defined in index 0 of the out label array. And adjacency is the layer 2 incap information. So yeah, so the basic idea, this is not really a BGP feature, it's a FIB feature. So what we want to do is architecturally, we want there to be a hierarchical sorting of these objects in the FIB. So it's a data plane system where you want to maximize the amount of sharing possible and keep a hierarchical linkage between the BGP prefixes and the IGP prefixes. This behavior is internal to the router. It's transparent to the operator and can be deployed incrementally, right? You can do this router by router. The idea is that FIB should be able to modify the path list of the IGP immediately and not have to backwalk to all the leaves. And we'll describe how you organize that architecture here. So here's a sample topology. Here you have the destination prefix that you want to get to. We're looking at the FIB forwarding at PE1. There's going to be an IGP, a set of IGP paths to two egress PEs. So there's two BGP paths that can get to any of these destinations. Right now, we're talking about 2 in this diagram, but this could be thousands, hundreds of thousands. And right now we have 2 IGP paths. So this is how you design the forwarding chain in the data plane. So the mapping is here. These destinations are here. These are what we described as leaves. So these are the prefixes, the leaves. So destination N, destination M. They both have the same remote next hop, remote destination. So these are the BGP PEs. Because they both are accessible or reachable through the same PEs, they have a shared path list. Then each of these PEs is reachable through IGP leaves. So IGP2, so the destination to reach PE2 is this IGP leaf. The reachability of PE3 is this IGP leaf. But in the end, again, both of them share a common set of paths. If you split up in this hierarchical way, it's pretty obvious now that if the IGP notices that there's a change in the link state, we need to update only a single shared path list, and the BGP routes can leverage that instantly. In order to maintain sharing, and in this example, we had an MPLS core, so these IGPs might be running LDP or SR. The labels obviously are unique, so those are separated out. That's why we have that label array separate from the shared path list. This lets the labels be independent, but the path list be shared, maximizing sharing. So I'll skip right now for handling limited hardware capability, but basically they go into the details about this depends on the hardware being able to support multiple lookups. So when the lookup for this destination happens, first we get the path list, the BGP path list. Then a second lookup is needed to find the IGP path list. So as the packet is hashed, either one of these paths will be chosen. Then we reach the IGP. Again, hashing needs to be done to pick one of the 2 path lists to get all the way to the adjacency. So the hardware needs to support that. They go into the idea of if there's more than just these 2 levels, how, if the hardware can't support more than 2 levels of lookup, that could be collapsed. But we can probably skip that for right now. That we can go into afterwards. So here's an example. So there's kind of 2 flavors of this BGP pick. There's the core failures, where within your AS, if there's a link failure or a node failure, how do we handle that as quickly as possible? And then the second flavor will be pick edge, which has to do with the remote PE's reachability or the PEC link at that end. We'll describe that afterwards. So here, in this example, to get to the destination N, PE1 is currently load balancing to PE2. And within the core here is the IGP. IGP finds a failure, notices a failure within 50 milliseconds, 100 milliseconds. Will then update that prefix. That IGP prefix converges quickly, and now PE2 can continue to flow. Traffic to PE2 can continue to flow through the newly converged IGP path. How that's done here. So here's again that hierarchy and the forwarding plane. We've got BGP leaves. We've got 3 here, but this could be hundreds of thousands, all sharing a common path list to that PE2. That PE2 then has an IGP leaf towards the single interface. So let's say interface 1 to next hop 1. When that interface fails, BGP or the IGP, ISS, or OSPF will reconverge, update only that leaf, and now all the BGP prefixes, no matter what the number is there, can take advantage of the new path. There's no need, BGP could converge at its own time later on, but FIB begins forwarding on the new interface as soon as it can, as soon as IGP realizes. This was the other flavor mentioned. This is for, again, we use the same hierarchical solution, but this is for when a PE becomes unreachable. So again, the IGP should realize that the PE is unreachable. And now the ingress PE, PE1, needs to have a pre-computed backup path. So it needs to learn multipath, so multiple outgoing egress PEs, and can pre-program the FIB with the other path. And when the FIB, when the IGP removes reachability to PE2, the FIB can instantly switch towards PE3, and trafficking will be corrected. And again, this does not depend on how many destination prefixes there are. As long as we have that hierarchy in the sharing, they all take advantage of the same shared path list. This is again how that's stored in the data plane. So we can have multiple prefixes, all sharing this. So all these BGP prefixes that have the same 2 destination PEs can share a common path list. They keep the service labels separate, but the path list towards PE2 and the backup PE3 are stored all together. So PE2 will be, the path towards PE2 will be programmed for forwarding. PE3 is pre-programmed and not in use until PE2 is found to be lost, the reachability is lost. That's when the path list at the FIB level can switch over to PE3 and resume traffic. And this is somewhat similar, a little bit more complicated use case. So in this case, PE2, maybe it's not the reachability of PE2 that is lost, but the PE-CE link is lost. It's going to take quite a while for PE1 to realize this, for this to be advertised that this link is now lost and pushed out. So instead, for quicker convergence, PE2 is also going to know that there's reachability through PE3 as well. We'll learn any labels needed for, let's say, a service label. If you have a perverf label, it will also know PE3's service label, and will take care of the corrective action itself. So if PE1 takes a while to realize PE2 has lost connectivity to that destination, it can continue to forward traffic towards PE2. PE2 will take care of converging towards PE3. Very similar forwarding chain to what we saw before. Some of the main differences, though, is at that destination prefix leaf, if it had made it to PE2, like if PE2 still had the CE link, it would have been passing that traffic as unlabeled. Whereas if it takes the backup path, it needs to use a swap label. Otherwise here, again, we have the same pathless sharing. The backup path does need a labeled path, IGP path towards next hop 2. Failure is seen by the IGP, locally detected. Reachability PE2 or to the CE is lost, and FIB will switch over to the PE3 and start using the swap label. So now we're going to swap our incoming label. So PE2's advertised label will be swapped for what PE3 is advertising, and the traffic will be pushed towards PE3. Yeah, so I don't know if we want to go into the flattening use cases, but really the idea was to describe this hierarchical data plane, the advantages of that. That if you can keep the hierarchy and not flatten, right? So generally in the past, I guess a lot of these platforms have been flattening. And my understanding, if it's correct, about SONiC today is that it is flattened. So these BGP prefixes will be flattened towards their immediate outgoing interface handle. There are advantages to that, right? That's you could have simpler hardware for those use cases. Probably pretty fast to program, high packet per second, right? The hardware does not need to do multiple lookups, but you lose out on this faster convergence. And there's other advantages to this hierarchy, right? You can have pretty significant memory saving, as each BGP prefix now only needs a pointer towards the common path list. So you store these large path list sets, could be 64, 1024, whatever it is. Store those once and share. Faster or better use of CPU as well, right? If there's this IGP update, we don't need to go back and walk all 1,000, 100,000 one by one BGP prefixes and update them towards the new path set. So I think that was pretty much the conclusion for here. So happy to take questions, or if we want to discuss more about this.
Yeah, thanks, Mike. So you mentioned earlier, like this is so you mean like in the implementation point of view, like a RIB, we could handle it completely. We don't need to basically the label array or the path in the list. We don't need BGP to providing. Is that what you mean? Or you say this one will be provided through the BGP?
Yeah. So BGP. I mean, for this to work quickly for BGP, right? Especially for like a link failure, you still need to have BGP. BGP will have needed to compute some other paths, right? You need more than one path. So either BGP is computed an ECMP or UCMP path list, right? If one of those paths go down, right? And that's specifically for that for the case of
you have the P3 for the ECMP.
Yeah,
right. So this is pick edge sort of protection. Yeah, we need somebody to pre-compute this and have that at the ready for FID to move towards as soon as the failure is noticed, right?
Yeah. My question is like say, what this information normally will be BGP will be responsible to creating the path list and also this label array, or it could be purely done because the zebra or RIB had all the information, so RIB can purely down and do that. Then you have pro and cons for that.
Yeah,
basically, like
sure.
I say, if you go back to the slide, if you go to one of the forwarding chain structure. Yeah, say for example, like let's take this as example. This one you have like on the top of the circle, this is the leaf. Then you have the label array, right? You have the P2 label and the P3 label. So this is the array. Then you also have the ECMP path between the P2 and P3. So my question for this one is like which one will be more efficient, because there are two approaches. So one is like these two objects will be created by the BGP. The BGP passing those information down to the RIB. Then RIB just maintain it. And the other option is like say BGP just regularly passes those information and RIB maintain it. So
I see. So you're talking about the
it's more like
communication
implementation detail. Yeah. So
that's implementation detail. Yeah.
So my Yeah, go
Yeah,
ahead.
maybe I can ask the same question actually differently, Eddie. I think I understand where you're coming from. So if I understand this, this primarily works if you have next hop recursion or reachability through an IGP. And the idea is that if the IGP is changing, you don't have to actually change the BGP prefixes because you already have the indirection built in. Whereas if there is IGP-less network, which is like typical BGP data center, I'm not sure how much useful this is.
Can you say it again? If the BGP data, what can you explain a little bit
So
more?
if it is IGP-less network, I mean to say that it's pure BGP, right? So the only thing that you see is actually the prefix and an ECMP next hop.
Oh, I see what you mean. Yeah, for the pure one, and because for the traditional data center network, that's why you see that it never come to the data center. Because for pure data center network, because everything is the eBGP, it basically it's IGP and there's no labels. So all the paths are
yes. So this solution works only if there is indirection. If there is no indirection, I'm not sure how useful this is.
But you see that previously we have two cases. One is from Alibaba and one is from the Microsoft, the crash which you debugged. That's a recursive case. So that will probably in the global table, my take is like if we add in the recursive support, it's not, but this is normally like it's a recursive route support. It's independent with these BGP picks.
Correct.
Because for that one, I feel like say if we supporting the recursive, then it's naturally will be solving the other two crash, which is the recent Microsoft crash, and also like Gongjian represented, like we see that all of a sudden like we flat into the 256 pass.
Yeah, yeah.
So that's
so you're right. I mean, if the recursion is there, then I mean, in terms of say FRR, I would say, and Donald can correct me. The Zebra can just update the next hop group that it already supports, because BGP session might still stay up if the IGP path is changing. And BGP is not even involved in that actually. Yeah, and so, this I would say it's already working the way it is supposed to work.
Yeah, but this one is more like I say the reason is I asking for this one is because for us for SRv6 VPN we do the recursive. Right, so we have the 1 million routes, which is and the BGP could be the VPN v4 routes over the v6 the IGP paths. Then IGP convergence should be independent with the BGP. So I have exactly the same problem which I need to solve in here.
And as Michael was saying, I think this should be handled in the RIB, which is Zebra in case of FR.
Yeah, so that's why I would say like that's why I want to pick Michael's opinion. If like say if this is then if we thinking that the RIB is the right place, the only thing the reason I would say if we want to handle in the RIB, then the issue is like we have the other features will be impacted. So say for example, like we have like say because in the FR code we have the OSPF and ISA code. I try to avoid touching those things. That's one part. The other one is we also have the regular layer VPN code. That probably say from the infra side we could make it working, but I don't know how much impact will be there. I don't know if maybe I'm overwhelming on that change. So I'm okay, like if we say we do it on the Zebra, then which means Zebra, but then what it means is that BGP doesn't, but the BGP probably still need to tracking that based on the next hop group. Yeah, today I think we don't do that. You know.
Yeah, so I'm really weak on. Sorry, I'm really weak on the SONiC use case and the Zebra today. So does BGP itself track next hop groups? Like, does it find common next hop groups between all the prefixes and try and share them? Is that what BGP does, or this is something that the RIB would have to do? If BGP sends down 1,000 prefixes that all happen to have the same in the end, they're all using the same path list. Would RID determine that there's a shared path list between them, convert that into a next hop group and download that independently? Or is that sort of your question, Eddie?
No, sorry. So I'm not sure if that today that like BGP is tracking that. I assume like Donna, maybe you can correct me. I think today we don't, right?
Don't what?
Basically, from the BGP level, we tracking the next hop groups.
Depends on what type of BGP networking you're doing. With BGP EVPN, it tracks next hop groups and can pass them down. With non-BGP EVPN, it doesn't currently. It just passes them down, and Zebra converts them and does magic. Having said that, I don't think it's I think part of this RFC here is that BGP can compute its backup paths and pass them down. Right? And there is the ability to pass backup paths down already. So BGP could be converted to use that. BGP could also be converted to track and forward next hop groups. And and internally at NVIDIA, we're kind of talking about that a little bit. See if we can figure out a way to make that happen. So the answer is yes. And I guess the answer is it's software. We can make it do whatever the hell we want to do. So
then you mean like, sorry. So today when for the VPN case, so I've been looking at the EVPN case. So in the EVPN case, or like I say, when it's the tracking, do they separate the VNet, those like I said, tenant information with the path, or they basically today it's like I say we're sharing based on the next hop group, which must be the common. So which means they have the same like the VPN context also.
I don't have an answer for that specific question. The I didn't implement that bit of code, and I actually had to dive into it. But effectively, if you're doing it's the I think it's the type 2 routes that we track. And
yeah, that is based on the ESI actually. The next hop group is created per ESI, and then the next hop group does exactly. Yep.
Okay. So you okay, I see, because within the same ESI, the VNet will be the same. Is that what you mean? So
yeah, I mean, so the ESI membership can change, right? And that does not mean that the prefixes have to be reprogrammed.
Yeah. And we just pass down an update of the next hop group when there's a change.
Correct.
Okay, I see. Because for us, we first want to see that how we handling the SRv6 the VPN case. So then for the SRv6 VPN case, we have like if from the BGP leaf point of view, we also have the path list which go into each of the remote P, and we also have a context. It's like the SID. The VPN SID is kind of like a label here. So let's consider this is more like a VPN context. For the VPN, MPLS VPN is just a label, but for the SRv6 it's a SID. So from Zebra,
So I think in your case, the labels are actually coming from BGP itself, right? They're coming along with the route.
Yes. I think that's not for the MPLS VPN case also, right? So it's
correct. Unless somebody's using LDP.
Yeah. Because for the VPN, LDP is for the IGP path. So that's why I kind of don't want to touch in the IG path. So I own, because for me, I feel I don't know if it's worse to do the IGP leaf, do the separation leaf, and that. For me, I would say doing on the BGP level for the path and the label array, this logic should be good enough, because the convergence normally like a BGP path have more prefix compared to the IGP. IGP we can tolerate it.
Correct. So I think in your case, because there are multiple prefixes sharing a given next hop.
Yeah.
If one of the route actually is withdrawn and you see that, okay, that label has to be now removed from the next hop, but you don't know actually which all prefixes are there which are pointing to the next hop. You cannot just go and change the next hop.
For the withdrawal case, that's different. So that probably will be okay too, because since you are withdrawing the routes, and we are talking about these couple of the failure cases, right? So the failure case, for example, if you have like say the core failure, then because it's IGP convergence, you suppose you're not touching the BGP. That's what we saw like today we do, because once we have IGP, we'll always tell the BGP, and the BGP always flushing. So that's something we probably track it and say, hey, this is something because there's no change in the path list, then all the passes, so we don't need the BGP to refreshing it. That's one part. The second part is like if the remote P go down, then we can use this one to quick converge, because that's the PIC was designed initially for the remote P go down. Yeah, this is Thanks, Mike. I can go back to the previous slide. No. The one you just showed. Yeah, this is the one. So basically say if the core facing like the P2 go down, then we try to avoiding like all the BGP prefix will be converged one by one, because that will take time. So that the beauty for the PICs, basically the BGP next hop group will be updated immediately based on the event. But then BGP can take time to recompute the path. So moving from the previous ECMP or like say using PE2 versus the PE3. Yeah. So that's basically where the PICs are showing the value. So because you can immediately swapping the for this case it's swapping from the active to the backup. But if it's the ECMP case, basically from 2 paths to be 1 path for the BGP level immediately.
I think backup path makes sense. I was a little confused on the ECMP path change, and this is what I was trying to say that.
No, that's really dependent on the BGP level. Do you enable ECMP or not, right?
Yes.
You could have like the BGP level ECMP or BGP active backup also.
Yeah.
The picture here is more like the active backup.
Correct. Yeah, that's what this one's displaying is. Yeah. This PE3 path is pre-programmed as a backup. It's been calculated by BGP, but it's not the best path at that time. PE2 is the best path.
Yes.
PE3 is the alternate best path. Yeah.
Correct. And this is pre-computed, and this decision to flip or switch over from prime to backup can be taken closer to the hardware, maybe in the hardware itself.
Exactly. Yeah. Yeah. If the hardware can learn locally through the IGP, let's say that the reachability is gone, the hardware can take action before control planes even realized and can update all their prefixes. Yeah. And it works best if there's multiple destinations that share these common PEs. That's what makes it prefix independent, right? The more sharing you have, the more prefixes that are behind PE2 and PE3, the more bang for your buck you get, right? That one interface going down can react. We can react once, and all those prefixes instantly learn that information. BGP will take longer to compute, re-download, serialize, right?
Yeah, but we are not trying to avoid the churn that is caused in the BGP because of this failure.
No, we won't, because the BGP will converge on its own. It just say like say the traffic, the loss window will be smaller.
Correct.
Yeah.
Yeah.
That's why, like I say, this one will basically say immediately to fixing the traffic in the fib, but the BGP can still, like I say, recalculate to say, hey, now P3 is gone. I need to switch into the P2 is gone and need to switch into P3.
Yep.
Correct. Yeah, you would expect that once BGP calculates this and downloads it, will actually end up being this same route, right? This now becomes the primary, and then later on it might compute a new backup, right, and protect this new path as well. Yeah.
So Hasan, like you mentioned in the, today we are not doing that, backup path programming in the hardware, but Zebra is doing for us basically. Before, BGP detects those IGP failures, Zebra level, the path will be corrected, right? And then it will be programmed to the hardware. And later BGP will detect and, it will be the same, right?
Yeah, I think in the typical data center, I would say there are two scenarios, right? One is the regular ECMP, and another is actually ECMP with the backup path.
Right.
Donald can correct me. I think there was some effort in FRR to actually add the backup path support. I'm not sure whether that was primarily for the MPLS or non-MPLS regular BGP network as well.
It was put in with is. So you can pass down, and it was done by Volta. But I'm not sure anyone's using it now, because Volta's kind of gone under the weather, right? So, but there's a backup path. You can pass down your, when you pass down a route, you can pass down the next hop group and the backup next hops, and we'll pass them down to the interested parties in the data plane, and Zebra will resolve the backup next hops that you pass down as their own next hop group and pass it down.
Yeah.
So it just needs that mechanism. Something needs to be programmed in BGP to compute the backup next hops and pass them down.
Yeah, and BGP can use the longer prefix, the longer paths that is not using as using in the ECMP calculation, that are the candidates for the backup path.
Exactly.
Good. Yeah. Another question, probably, Michael, I want to pick a little bit your opinion on that. It basically for this is specific for the SRv6 because today for the SRv6 the VPN context has a aggregate prefix ID, right? Or basically using that, then all in the Silicon One today, it's like it doesn't maintain the label array. It's maintained as each of the BGP next hop, he maintains the MAC table. So my question is like in that case, how do you indexing the two questions? One is like, say, who will be the owner for that the prefix aggregate IDs today? Like in your implementation will be in the BGP, or it's in the Zebra, or in the RIB. The second one is like, say, do you still passing down the whole array and down, or you are organizing it in the fashion of whatever the hardware expected?
So you're talking about when you're encapsulating into SRv6? Is that the question?
Yes. Yeah, that's true.
Basically, encap.
Let's assume that your PE, or this is the SRv6 cases, then we have the PE1 will be the encapsulating, and this is basically the V4 VPN routes on your N side. Then your P2, P3, basically the decap portion of your SRv6. So conceptually will be very similar. But previously in XR, you have the a label array, which just like what you show in the graph, right? So this is the object which you're passing down to the hardware. But today in the Silicon One, their implementation is a little bit different. They introducing the aggregate in the prefix IDs. So it's kind of like, say, label array is more like a vertical cut. Basically, say for each prefix, what are the label they have? But the aggregate ID is more like a horizontal cut based on each of the next hop, the BGP next hops. What are the possible, like, say, BGP labels will be in this map? So my question to you is like, say, for that particular one, do we need to design separate the passing down, like I say, from the fib, from PI fib to PD fib or hardware, those kind of object, or we can leverage existing, like I say, label array, which you're showing here.
Yeah, I'm not sure I could answer that. So I'm not so familiar with the Silicon Silicon One implementation.
Oh, that's fine. Yeah, I just
Yeah.
want, but you didn't have the, so let me ask the other question. Do you add any new PI object there? If you don't, then I know you are using the label array.
No, definitely. Yeah, at the PI side, yeah, we are treating this like a label array, but it obviously label array stores 20-bit values. This is different, right? We're storing SRv6 SID prefixes, right? Yeah. So we had to change the storage, but the idea is similar. Yeah, this is
similar. Okay. So then it's purely like the PD fib, the handling part.
Yeah.
Oh, gotcha. Okay, thanks. So basically, now I understand how we can handle it.
Right.
Then, because this is a part of the prefix context, I could using your basically leaf and the array, then I can derive in it.
Right. Yeah.
So that's what I was saying, because this is the Silicon One behavior is different with the like PI fib original design. Yeah. But even though if not changing, then I aware then I understand how this could handled. Yeah.
Okay.
Good. Yeah. So today, like the label array, these are maintained in the fib, right? In the PI fib domain. The pass list and label array, right?
Yeah, exactly. So can I put back through here? Let me show an example. Yeah, so as far as sort of like the RIB side, the PI side is concerned, we still download each prefix, like the prefix is going to be downloaded with a path list and with a labels associated with that path list. And then PI fib will break that up. Like PI fib is responsible for kind of separating the most shareable section from the unshareable. Like labels are generally not shareable, right? Every service will have a different label, but the path lists will likely be the same. So it will kind of break those into two and then see this path list that I just generated. Do I already have it in my database? Can I just point to an existing one, right? So it's looking for the sharing.
Gotcha.
PIFib will look for the sharing and keep anything that makes most path lists unique, keep that as a subset of the data hanging off the leaf.
Gotcha. Right? Good. So basically from the BGP to the RIB, it's basically say, this is my prefix, this is my path, and this each path basically is more like the information you learn through the BGP. You get the next hop, you get the context, the VPN context, like labels.
Yeah, exactly.
Then you will separate them to be, hey, this is something I can share at the path list, and the other one will be the VPN context, which is unshareable.
There's pros and cons to having BGP do it or FIB do it, right? FIB, then it's common, right? You have one implementation, not every protocol needs to re-implement.
Yes.
But then there's disadvantages, obviously. Now, if BGP had been aware of it, there probably could have been an optimized IPC between BGP and RIB, right? So it's pro and con. Yeah.
Gotcha. Good. Yeah. That's good. Yeah. I feel like say forever, whoever want to using the FR in to do the like say real like layer 3 VPN, like me, I was using the SRv6 VPN, then we probably need to have this one enhanced to improving the convergence, because we try to avoiding to have a millions of routes always become reprogrammed. Yeah. Good. Okay. Good. That's good discussion. Any other comments from other folks?
So Eddie, what is the outcome of this discussion? Is anyone gonna contribute this feature to SONiC, like backup path programming and all that? Or
Yes, that's what my goal.
okay.
Yeah, so that's why I wanted like Mike to give this the group of people to add. I know so that's definitely some people already know that very well. Some people probably new to that, but that's why I'm looking for the contributors. And also like this last time, like the Acton folks who joined, they want to help on here as well. That's why we want to, from the community point of view, let's come up with some kind of like say HLD for these picks. Yeah, because this could be benefited to a lot of people. So, yeah.
Okay. So it's again based on it's based out of FRR or like some other routing module that you want to.
I think we only do the FR, right?
Yeah.
Or at
I mean,
least
there are Juniper routing stack and all those things are being run on SONiC, but not as a community thing. But yeah, there are other options as well. So.
I will let the Juniper guys to take it there. I think they should already have the picks.
Yeah, I don't know,
that
but
is run
the
in
hardware
a
side,
separate
no.
container.
Yeah.
Oh, okay. Yeah, but for us, we cannot using those. We fully betting on this in Alibaba case. We fully betting on the FR code, so
Yeah.
that's why we want to enhance it. And also, I know that probably some other folks are also betting on the FR code.
Right. Yeah.
So there are two things which I want. One is definitely the pick. This is the one. The other one is just a recursive case. Recursive probably will be easy to handle, but I want to. I don't want to see that the 256 in the ECMP passes.
Yeah.
But that probably will be the low hanging fruit.
Yeah. I don't remember the kernel does support recursive thing right now. You can program the thing, or I don't know any
I don't think a kernel can do that.
Okay. I remember some recent kernel changes for that. I don't know. I don't know.
But that recursive one, we probably need a new side support, right? Because side today doesn't supporting the next hop over the next hop, right?
Yeah.
Yeah, you mean to say the backup next hop?
Not only the backup, I would say just like a two-level low balancing.
Or the hierarchical next hops.
Yeah, hierarchical. Yeah.
Primary, and that's also the good one to have, but I would say the first hierarchy is more common. Just like in my case and also my Microsoft case, it basically is hierarchical. I think today the hardware pretty much everybody can support a hierarchical, right? Hassan, right?
Yeah, actually, if you see any of the overlay next hops are going to be hierarchical anyway, right?
That's true. I think EVPN naturally is a hierarchical because
yes.
But global table today they are because the FR flapping it.
Correct.
So it's not. Then if we want that one to be hierarchical, then we need to enhance. So basically, we need to let the zebra passing down those next hop group, and also we need to add the side support to introducing this like the low balancing over low balancing concept.
Yeah, basically programming a prefix with the hierarchical next hop.
Yes. Then your hierarchical next hop will be, because today next hop member is always be the next hop. Now we need to say next hop, it's recursive, so it could be over another.
Correct.
Hop.
Correct.
Yeah.
And independently, the level 1 or level 2 next hops can be updated.
Yes.
Without changing the prefix.
Yeah, there'll be some amount of change will be, yeah.
Yeah, and also the backup path actually.
Yeah, backup path is definitely also needed.
Correct.
Yeah. For us, the backup path will be good, like I say, for those AI infrastructure. Like I say, once the link go down, we want to have a quick convergence fast.
Yep.
So that's why I would say, like, after the Michael's one, we probably have need a couple of meetings to discuss how we implement the PICs in the current code base, FR and SONiC, and maybe side changes. So that's another one I want to get the community working together to come up with the HLD and eventually get people to contribute to making it's working. Yeah. Good. Good. Anything else you want to add? Good.
So
yeah,
I just want to touch upon actually the one of the common scenarios with the IGP-less network is the link failures, right? You don't have hierarchical next hop because there is no IGP there, right?
Yes.
And one of the path goes down. I'm not sure. I mean, today, if you see from SONiC's point of view, actually, it is the ORC agent which is reacting to the port down and then removing that leg or path from the ECMP.
Yes.
That is the closest it can do.
Yeah.
Correct. And I mean, the port down will anyway trigger the BGP down eventually, and all of the routes will have to get reinstalled with the new next hop group, which will have that path removed.
Yes.
So I think there are two parts to it. One is there a way to minimize the amount of time it takes to actually update the hardware when the path goes down? The second is, can BGP PIC help in minimizing the churn that happens when a path goes down? And I don't know whether actually this draft is helping in any of these two cases.
I doubt, because this is more like one level ECMP path handling.
Correct.
So this probably say should be done in the FIB, which we can marking the, because based on link down, we marking the, so that's why we did it in OP agent, right?
Yes.
Because today the Zebra doesn't have this concept because Zebra is flat.
Correct. In case of SONiC, actually, even if Zebra is doing, it will be even slower than actually ORC agent handling this thing.
That's true. Yeah.
Yeah.
But sorry, you mentioned that ORC agent does have a next hop group, right? So there is
correct.
There is that hierarchy. Then you have a bunch of prefixes all, I'm assuming, sharing a common next hop group, right? So if the next hop group can be updated quickly,
that is the day one design.
Yeah. So that is part of the PIC architecture, right? The idea of finding sharing as much information between prefixes, right? So that when an event happens, you don't need to walk each prefix. It's independent of the number of prefixes. The more sharing you have, you're only updating next hop groups, right? And FIB, if FIB can react fast, right? If FIB knows that this next hop group depends on this interface, and when the interface goes down, to quickly update it, that's better than walking all, having that dependency between the interface between all the leafs themselves, all the prefixes.
So I think then the question goes to you actually, Michael, that I mean, over a period of time, people have anyway realized, and I would say all of the implementations already use this hierarchy, that the next hop is not with the prefix, but next hop is actually a separate entity than the prefix, right? And so that was the starting point. I was reading the draft, and I think that was the starting point, that the next hop should be separated from the prefix. But that is I mean, an age-old problem, and I think everybody has already agreed on it. But then this is still a draft. It has not become an RFC.
That's this one, I would say it's doesn't really matter because it's more like implementation for this draft. This is more like say how we handling it could be quicker. I would say even it's a draft, not draft, is because it's only like one box solution, so it's not really a big deal. Because you don't even communicate with others.
Correct. It's called BGP PIC, but really it could be any, like you mentioned, EVPN or pseudo wires. It could be almost anything, and it's not a change to the BGP signaling other than kind of adding requirements, right? Adding the need for backup path computation, things like that. But it's not and whatever the signaling is to do that. But yeah, it can be done on each router independently, right? Yeah.
Yep.
But back to the Michael, current, this is more like architecture discuss, because for me, I would treat the awk agent as more like a PD FIP. Then if in that case, I would try to give less intelligence in awk agent. Because today, like I say in Cisco XR, like I say, the most intelligence in the RIP, even PI FIP has a little bit, not much. So, but the RIP itself had the organized because you have the folding structures, right? For the folding object to give to the FIP.
In XR, actually, XR FIP is responsible for a lot of this.
Oh, really? Okay.
This forwarding chain, yeah, it's responsible for finding these common next hop groups, these paths. Yeah.
Gotcha. Okay. Good. Okay, that's a good discussion. Yeah.
Yep, indeed.
Yeah. Mike, can you send me that slide so I can upload into the group wiki?
Yeah, for sure.
Yeah, thanks. Yeah, and for the next week, I think Hassan, you were talking about the async callback, right?
Yeah, we'll briefly talk about the async SI.
Good.
Yep.
Yeah. You need like say like half the time, or you need the whole?
Yeah, I'm not sure how many. It depends on the questions. Maybe we can target for half. And if there are more questions, we'll anyway extend it.
That's fine. I will give you like the whole thing. If then I just ask. I have two more like I say interns haven't been presented their part. So if you finish early, then I will let them to present. Otherwise, probably the following week.
Sure. Yeah, that makes sense.
Yeah. Good. Okay. Cool. Okay. Thanks. Thanks, everyone.
Yeah. Thanks, Michael. Thanks a lot.
Thanks, Michael.
Thank you.
Bye.